While Tesla is still just sketching out a vision of automation and a robot revolution across America, on the other side of the globe, China has already built a literal army of robots. They're appearing everywhere, from factory floors and offices to everyday home life. Instead of grinding through long mornings at the office or struggling with daily household chores, these tireless machines will handle everything for you. In just 10 years, you won't be able to tell the difference between a human and a robot anymore. How did China pull so far ahead of the rest of the world? Before we dive into how all of this robotic technology is being built, hit that subscribe button so you don't miss the tech analysis that is shaping our world. For decades, China was known as the factory of the world, serving as a massive manufacturing hub for Western tech giants. However, instead of remaining a contract manufacturer for powers like the US or Japan, China made a strategic pivot, investing heavily in artificial intelligence, robotics, and core technologies to emerge as a new technological powerhouse. The turning point became clear in the early 2010s, and specifically after the Made in China 2025 strategy was announced in 2015. Its goal was simple yet ambitious: to put China at the forefront of industrial robotics, AI, and smart manufacturing. By 2017, the National AI Development Plan was deployed, driving a wave of investment into robotics and automation from both tech giants and startups alike. At the heart of this entire ecosystem is Shenzhen, a city often dubbed the Silicon Valley of hardware. It is home to the world's largest supply chain network for electronic components, sensors, and servo motors. Thousands of factories are clustered within a radius of just a few dozen kilometers. This allows robotics companies to design, test, and produce prototypes at breakneck speeds, sometimes in just a few weeks, compared to the months it would take in the US or Europe. This sheer speed has become China's ultimate competitive advantage. It is a lightning-fast innovation cycle. When combined with massive capital from tech giants like Tencent, Baidu, and Alibaba, this ecosystem began giving birth to a brand new generation of robots led by the Astrobot S1 is one of the most sensational humanoid robots on the internet in recent years. Not because of its human-like appearance, but because its mechanical speed and dexterity have far exceeded what most of us ever thought a robot could do. In test videos, the Astrobot S1 can slice vegetables, flip pancakes on a hot pan, pour water into a cup, fold shirts, and organize kitchen items with near-perfect precision. It performs tasks that were previously only possible for expensive industrial robotic arms and factories. But what truly caught the attention of robotics engineers was not just that it could do those tasks. It was the speed. The arm joints of the Astrobot S1 can move at velocities up to 10 meters per second, which is faster than the reflexes of most humans and sufficient to handle operations requiring extreme precision in an incredibly short amount of time. However, speed alone isn't enough to make a robot useful in real life. If the grip is too strong, an egg will shatter, and if it's too weak, the robot won't even be able to lift it off the table. And this is where the technology behind the Astrobot becomes fascinating. This robot is trained using an AI method called imitation learning by mimicking human behavior. During training, an operator wears a VR headset and control gloves to perform real actions in a virtual world, from holding a knife and flipping pancakes to folding clothes. The robot observes these entire movements, and the AI then analyzes the hand trajectory, joint angles, and impact force to interpolate how to recreate the action with many times more accuracy. In other words, the robot learns by imitating humans, but it executes those tasks with the consistency of a machine. If the Astrobot S1 represents the limit of mechanical dexterity, then the robot standing right next to it in this race breaks a completely different barrier: price. While the United States takes pride in the Tesla Optimus or Boston Dynamics, on the other side of the globe, a hardware revolution is turning these expensive machines into affordable consumer goods. The Unitree G1, a humanoid robot developed by Unitree Robotics, didn't shock the world with acrobatics or the ability to stand back up when pushed. It was the number attached to it: $16,000. For many years, humanoid robots were seen as extremely expensive machines. Humanoid prototypes in the US or Europe often cost hundreds of thousands or even millions of dollars when research costs are included. But Unitree has done what many other robotics companies never could: turn a humanoid robot into a genuine commercial product with a price tag roughly equivalent to an entry-level car. That changes the game entirely, because for the first time in history, a humanoid robot is no longer just a laboratory demonstration device. It can become a household appliance. To achieve this price point, Unitree leveraged two critical technical factors. First is the use of reinforcement learning, a method that allows the robot to teach itself how to move and balance through millions of trials in a physics-simulated environment. In that virtual world, the robot constantly falls, loses balance, and learns to stand back up until the algorithm discovers the optimal movement strategies. By the time it enters the real world, the robot practically already knows how to walk before taking its first actual step. The second factor lies in the advantage that China possesses: a massive hardware supply chain. Micro servo motors, motion sensors, and lithium batteries are mass-produced domestically at costs much lower than in Western markets. This allows Unitree to drive the robot's price down to a level that was previously unimaginable for a humanoid. The result is a machine that can perform staff martial arts, maintain balance when kicked, navigate flexibly across various surfaces, and even fold up compactly to fit inside a suitcase. A humanoid robot, faster than a human. And it is beginning its first steps toward replacing humans with precision as speed and price become more mainstream. The biggest question is no longer whether robots can replace humans. Now that robots serve daily life in the consumer market, it is impossible to overlook the technologies quietly operating inside massive industrial factories, where modern production lines run almost non-stop to create millions of products every year. There, humanoid robots are no longer just laboratory demonstration machines or viral internet videos. They are starting to put on safety vests and step directly onto heavy industrial production lines, working side by side with human workers in environments requiring near absolute mechanical precision. One of the clearest representatives of this trend is Walker S, a humanoid robot developed by the tech company UB Tech. This Shenzhen-based robotics enterprise is considered one of China's leading names in the race for industrial humanoid robots. Unlike many other humanoid robots designed primarily for research or tech demonstrations, Walker S was developed with a very specific goal: to become a true robotic worker in modern superfactories, where robots must be able to move flexibly, observe their surroundings, and perform multiple different tasks on the same assembly line. In real-world trials on automotive production lines, Walker S can walk along the assembly belt, using its camera system to inspect safety latches on car bodies, paste brand logos onto hoods, tighten bolts at fixed positions, and even transport components between workstations, tasks that previously required humans or specialized industrial robotic arms. What sets Walker S apart from traditional industrial robots is that it is not limited to a single task. The same machine can take on various types of work simply by updating its control software. This is particularly vital in modern factories where production lines constantly change to adapt to new product models. To perform such high-precision tasks, Walker S utilizes a control technology called visual servoing, a method that combines computer vision and robotic control, in which depth cameras continuously scan the surroundings to create a detailed 3D spatial map of the work area. Based on that spatial map, the robot's control system can pinpoint the exact location of every screw, every assembly point, every component on the car body. Simultaneously, it calculates the exact amount of torque needed to secure the component without scratching the paint or causing structural misalignments. This entire process happens in near real time, with algorithms constantly adjusting the robot's movements to ensure every operation achieves sub-millimeter mechanical precision, a mandatory requirement in modern automotive manufacturing. More importantly, Walker S does not operate as an isolated machine, but is connected directly to the factory's production management system. Every vehicle moving on the line is tracked with real-time data, allowing the robot to know exactly which car model is approaching its workstation and which specific operations need to be performed. It is this combination of computer vision, precision control systems, and data connectivity with the entire factory ecosystem that makes it so effective. Walker S is gradually becoming a fixture on the production lines of major electric vehicle manufacturers like BYD and NIO in Shenzhen. There, robot and human work together in the same production, space biology on one side and mechanics on the other. But both are connected to the same data system and driven toward a common goal, optimizing the speed, accuracy, and efficiency of the modern production line. While robots like the Astrobot S1 or Walker S impress us with mechanical speed and industrial power, there is another branch of robotics that many find far more unsettling. Not because they are strong, but because they are too human. In service industries like museums, exhibition centers, or tourism, robots don't just need to work accurately, they need to interact naturally with people. This presents a completely different challenge than industrial robotics. A machine can talk, but if its face is as rigid as metal, the human brain immediately detects the dissonance. In neuroscience, this phenomenon is called the uncanny valley, describing that eerie sensation of discomfort we feel when a robot looks almost human, but not quite enough to fully deceive our visual nervous system. To break through this psychological barrier, one Chinese company chose a bold path. Instead of making a partially human-like robot, they decided to go for total realism. That company is EX Robots, and their products are hyperrealistic androids. These machines possess silicon skin that is soft and warm to the touch, complete with wrinkles, pores, and even the natural blinking rhythm of a real human being. But what truly impresses engineers isn't just the outer skin, it's the mechanical facial muscle system beneath it. EX Robots androids are equipped with over 140 facial motion mechanisms, allowing them to recreate a wide array of subtle expressions, smiling, frowning, furrowing brows, or tilting their heads in thought, a range of expressions often broader than those of most humans. To create these lifelike faces, engineers spend nearly a month hand-molding medical-grade silicone skin before installing dozens of micromotors underneath to control specific muscle groups. One motor lifts the corner of the mouth to create a smile, another gently pulls the forehead to form wrinkles during thought. They all coordinate to produce expressions that appear almost entirely natural. That is why these androids are connected directly to large language models, LLMs, specifically Baidu's ErnieBot. This allows the robot to hear questions, retrieve data, and generate responses almost instantaneously. The fascinating part is that the facial expression system is synchronized with the conversation content. The robot can smile while telling a joke or knit its brows when answering a serious question. Today, these androids have already started working in the real world. A prime example is the EX Future Science and Technology Museum in Dalian, where visitors can chat face-to-face with robots in the likeness of Albert Einstein or Steve Jobs. These historical figures, recreated as robots, can tell stories, answer questions, and react to the emotions of the person standing in front of them. When a robot can speak like a human, emote like a human, and remember information better than a human, a compelling question arises. In the near future, will we even be able to tell the difference between a human and a perfectly programmed machine? The answer to that question will likely have to wait another 5 to 10 years. But one thing is very clear right now. Robots have already begun to infiltrate human life. For years, we often thought of robots as cold metal machines. No emotion, no personality, and certainly incapable of creating any kind of bond with humans. But reality is beginning to prove the opposite. Robots aren't just taking on human forms. They can also become creatures that humans find much easier to accept, such like pets. In recent years, four-legged robots, or quadrupeds, have become one of the fastest-growing forms of robotics in the world. And in China, a robotics company called Unitree Robotics has created some of the most agile quadruped robots ever built. Their names are the Unitree Go 2, and the more powerful industrial version, the Unitree B2. At first glance, they resemble a compact mechanical dog with 4 metal legs and a suite of sensors mounted around their bodies. But behind that exterior lies a complex mechatronic system that allows the robot to move through environments that many other robots simply cannot access. They can climb stone stairs, wade through water, maintain balance on slippery surfaces, and even carry dozens of kilograms of cargo while navigating steep terrain. In tests, these robots can reach speeds of up to 6 meters per second. That is faster than the jogging speed of many people. But what catches the attention of robotics engineers isn't just the speed, it is the environmental awareness. The Unitree Go 2 is equipped with a 4D LiDAR system combined with cameras and motion sensors, constantly scanning the surrounding space to create a 3D environmental map with a 360-degree view and 0 blind spots. Thanks to this, the robot can detect obstacles at a distance of just 0.05 meters and adjust its steps almost instantaneously. But seeing the environment is only half the battle. The rest lies in how the robot maintains its balance. To achieve this, Unitree uses a motion algorithm called dynamic gait, which allows the robot to continuously recalculate its body's center of gravity thousands of times per second to stay upright even when slipping or facing external impacts. This allows the robot to flip, jump, climb slopes, and move stably in conditions where many other robots would fail. Today, these four-legged robots have begun appearing in many real-world missions. At the Asian Games, they were used to pick up the discus and zip across the stadium. And at Mount Tai, one of China's most famous mountains known for its thousands of steep stone steps, Unitree Go 2 robots have been deployed to haul cargo and collect trash on the stairs, replacing the grueling labor that previously required human effort. Looking at robots like the Astrobot S1, Walker S, or Unitree Go 2, it's easy to assume that China has secured an absolute lead in the robotics race. But the reality is far more complex because this revolution is unfolding simultaneously across the globe. In the United States, Tesla is developing the Optimus Humanoid with the ambition of making robots a mainstream consumer product, while Boston Dynamics continues to push the limits of dynamic robotics with machines that can run, jump, and maintain balance in extremely chaotic environments. Meanwhile, in Japan, giants like Honda and Toyota remain focused on service robots designed to support an aging society and provide personalized human care. The true differentiator for China lies in its speed of deployment. While many Western robots are still in the R&D or experimental testing phases, Chinese companies have already begun integrating robots into factories, airports, restaurants, and even harsh natural landscapes. Machines like the Walker S or Unitree Go 2 are moving beyond the tech prototype stage and are rapidly becoming mass-producible commercial products. But along with these opportunities come massive questions. As robots become increasingly intelligent, faster, and cheaper, what happens to the jobs that humans perform today? How do we balance a more efficient economy with the reality of a shifting labor force? Whatever the answer may be, one thing is already crystal clear. The robotic era is no longer a concept for the distant future. It has already begun. In just a few short years, robotics has crossed a threshold many thought would take decades to reach. What makes this specific moment in history unique isn't just that robots are becoming smarter or more agile. It is the sheer velocity of the technology's evolution. These machines are simultaneously becoming faster, more precise, and most importantly, cheaper. This shift is moving robotics out of the realm of expensive R&D projects and into mass-producible products ready for deployment across the global economy. As technology reaches the point where robots can move like humans, work tirelessly, and be manufactured at a fraction of their former cost, the central question of the robotic era changes. It is no longer a matter of whether machines can replace human effort, but rather how we will adapt to a world where robots are ubiquitous from our factories and city streets to the very heart of our homes. So, in your view, will robots become the essential partners that finally liberate us from grueling labor? Or will they become direct competitors in the future job market? Share your thoughts in the comments below. And if you want to continue exploring the technologies that are defining the next decade, Don't forget to subscribe so you don't miss our upcoming deep dives.